When you're working with data types in Java, and specifically characters, it's important that you understand how characters are actually represented in Java. So the Java char type is a 16-bit primitive type used to represent a Unicode character. So the Unicode standard is just a way to represent text characters, so things like letters, digits, punctuation, shapes, and so forth, in a data type. So each one of those entities gets a specific value in the Unicode standard. So the first 128 values, which are values 0 through 127, they map to an older encoding, which is called the ASCII standard. And then each one of those numbers maps to something specific. So for this example, values 0 through 31 are some control characters, like the null, end of the line, backspace. If you really want to be annoying, there's a bell character that doesn't display, it makes a sound. But where we'll be mostly interested in would be things like the Arabic numerals 0 through 9. Those are encoded with values 48 through 57. Uppercase Latin letters, lowercase Latin letters would be 65 through 90 and 97 through 122, respectively. And then you'll notice there's some gaps there. Those gaps are filled in by various types of punctuation. So every one of these individual characters has an encoding as a number, and that's what's stored in our char data type. Now, a char is 16 bits, so it holds a lot more values than those. There are Greek characters, arrows, mathematical symbols, geometric shapes. I think there's some emojis in there, and then also the characters used in other languages. So there's a lot there, way more than you can memorize. I definitely recommend that you take a look at a Unicode character table to see how those mappings work and just to see what sort of options you have. Again, this isn't something you're going to want to memorize. You can always just reference a Unicode table to get those values. So where that comes into play for us, here I have a program where I have declared a character, and then I'm going to print it out. And when I run this, I get an A as my output. Now that's not super interesting, but what if I do this? If I cast that character value to an integer, so this says treat what follows as an integer. So it's a character, it's going to treat it like an integer. And when I run this, you can see that I get the value 97. And helpfully, I can use Wikipedia to get a map of those characters. So again, here you see the control codes that we see at the beginning. And then if we scroll down, we're getting into our Latin characters, and a lowercase a has the decimal value 97, which is what we see here. Suppose I wanted to do a different character. So let's take one of these other characters. Let's use a W, which is character 87. So if I create a char and assign it the integer value 87, and then do the same thing I did with character 1, I'm printing it out exactly the same way. When I run this, you can see I get W and 87 as my output. And again, this is because we're representing characters with integer values. So as it turns out, these character literals, the single characters enclosed in single quotes, are actually interpreted as integers. So I could do something like this. Char3 is equal to A plus 10. Now when I print that out and I run, notice character 3 is actually K, because A is actually the ASCII value 65, plus 10 is 75, and K is the character that has the Unicode value 75. Now, I think I'm using ASCII and Unicode interchangeably. For these early values, they are the same, and my background is in C programming, and so I still refer to the ASCII character set. But keep in mind, for those first 128 values, ASCII and Unicode line up pretty much the same. So whichever one I use, keep in mind that since we're talking about Latin characters, ASCII and Unicode both mean the same thing. I think the question that comes up now is, okay, I see how characters and integers are related. Does that relationship go in the opposite direction? So I'm going to say int1 is equal to 122, and then I'm going to create another integer, and I'm going to say that that's equal to lowercase r minus 12. And notice there's no errors or warnings other than I haven't used this yet. So let's print this out, but then I'm also going to print this out as a character, doing the same thing I did before, except now I'm going to cast the int back to a char. And I'll do this with int2 as well. And when I run my code, you'll notice that int1 is 122, that's the character's lowercase c, and int2 I initialize to lowercase r minus 12, so that gives me 102, which maps to character lowercase f. So you'll notice I'm actually able to do arithmetic with character literals. So hopefully that gave you some insight into how char and integers are related. This allows us to do things like encryption and so forth, where we're working with the characters as numbers. Numbers are a more native to the computer type of data type, so we're able to do arithmetic and so forth on those.